Hello, my name is Austin Holton, and I am an AP Chemistry student at Bayport High School. Today we'll be covering topic 7.6, which is the properties of the equilibrium constant. In this video, we will show how to represent a multi-step process with an overall equilibrium expression using the consistent K for each individual reaction. Here are some of the main points. When a reaction is reversed, K is inverted. When the stoichiometric coefficients of a reaction are multiplied by a factor C, K is raised to the power C. When reactions are added together, the K of the resulting overall reaction is the product of the Ks for the reactions that were summed. Since the expressions for K and Q have identical mathematical forms, all valid algebraic manipulations of K also apply for Q. Let's do a little bit of recall. So here we have the equation x is equal to y. So for the K for that value would be the concentration of x divided by the concentration of y. Recall that the brackets mean concentration. Here we have 2x to 2y. So the K value for the second equation would be the concentration of x squared divided by the concentration of y squared. Finally, for the third reaction, we have 1 half x to 1 half y, which the K for that would be the concentration of x to the 1 half power divided by the concentration of y to the 1 half power. Continuing off of this, let's say that the concentration of x equals 10 and the concentration of y equals 2. So here we have the first reaction again, first equation. So the K would be the concentration of x divided by the concentration of y. So the K for the first equation would be 10 divided by 2, which equals 5. Next, we have the second equation, 2x goes to 2y. So the K would be the concentration of x squared divided by the concentration of y squared. The K for that would be 10 squared divided by 2 squared, which equals 25. So the K value for the second equation is 25. Finally, for the third equation, we have 1 half x to 1 half y. So the K would be the concentration of 1 half, or the concentration of x to the 1 half power divided by the concentration of y to the 1 half power. So the K would be 10 to the 1 half power divided by 2 to the 1 half power, which is approximately 2.24. So the K value for the third equation is 2.24, approximately. Note that when we reverse a reaction, we take the inverse of K, which is known as 1 over K, or K to the negative 1 power. So let's look at the equation. Let's look at this right here. 2 NaCl to 2 Na plus diatomic chlorine. So the K of the forward reaction would be the concentration of Na squared times the concentration of diatomic chlorine divided by the concentration of NaCl squared. So let's just say for this that the K value of the forward reaction is 20. Then let's look over here. We have the same equation, just reversed. So we have 2 Na plus diatomic chlorine to 2 NaCl. So the K for the reverse reaction would be the concentration of NaCl squared divided by the concentration of Na squared times the concentration of diatomic chlorine. So let's say the K for the reverse reaction would be 1 over 20 because the K for the forward is 20. So it's inverse. Also note that to find the overall K for a reaction, multiply all the K values together. So let's look at it. So we have V to W, and let's just say that that K value is 3. So we have W to X plus Y, and let's say that K value is 6. Finally, we have X plus Y to Z, and let's say that K value is 8. So to find the K value from V to Z, we have to multiply all the K values we have. So the overall K value from V to Z is 144, which is relatively product heavy. And K is when we are at equilibrium, Q is when we are not at equilibrium. So everything that we talked about apply to K and Q since they coincide. And just for a quick recap, when a reaction is reversed, K is inverted. When the stoichiometric coefficients of reaction are multiplied by a factor C, K is raised to the power C. When reactions are added together, the K of the resulting overall reaction is the product of the Ks for the reactions that were summed. And then since the equations for K and Q have identical mathematical forms, all valid algebraic manipulations of K also apply to Q. Hopefully this helps you with 7.6. This has been my presentation. Thank you for listening.